Okay, good morning. And let's see. Welcome to the final week of the Geo-Python course. Let me get myself organized here just a little bit and we can get started. So, yeah, thanks for those who are filling in the poll questions. We can continue to have you do that while we're getting going here. I think maybe I'll just one more time put the poll link into the chat. So if you haven't had a chance to fill in the poll questions, you may do that now. And yeah, it looks like we have a decent number of responses there. So that's good. I think the theme here seems to be something about the difficulty of this exercise. And this is something that we're kind of aware of, that this exercise in week 6 is definitely more challenging. And I'm sorry to see people finding it perhaps too challenging, but we are definitely understanding on this situation. So maybe, yeah, I'll start by just going through some of these poll responses and then we can continue on from there. So, yeah, I think all of you can see here the sort of overall picture of the difficulty of exercise number 6. I suppose it really wasn't our intention that exercise 6 would be substantially more difficult than the previous weeks, but it is a bit of a leap in terms of what you're doing and what you're combining in this exercise. So there are some things that are introduced in the lesson, and I think we just combine a number of them here in week 6, that pretty much every year this exercise is noted as one of the most challenging. And in a sense, I think if you figure it out, it's one of the most rewarding exercises, but definitely it is not the easiest of the exercises. So there's questions here, it looks like, on part 1 and part 2 for this exercise. And otherwise, yeah, I mean, it looks like it took quite a bit of time to complete this. And in some cases, I mean, when I see 2 work days or 3 days, I think that's definitely not what we're hoping in terms of how much time it takes to complete the exercise. But of course, I'm not questioning that that's how much time it took you. Just in that sense, I feel like maybe that's a bit of a failing on our part, because we should be able to provide some guidance and assistance for you so that it shouldn't take that much time to complete the exercise. It's a harder one and it should take longer than most of the other exercises to this point, but it shouldn't be that it takes several days to do it. And yeah, this is, I think I had made a sort of suggestion that you take the opportunity to go to the exercise sessions for this week. Given that there's so much difficulty that's here, I think one thing we could do at least would be to extend the deadline on this one, so that maybe this exercise 6 you guys could have until the end of the week, so that if you have questions still for the course assistance in the exercise sessions, you could take those questions there and get some assistance so that you're able to figure out how things work. It's, yeah, I mean, I wouldn't say that it's out of your reach. I mean, we don't want to make exercises that are so difficult you can't complete them. We do want to challenge you, but I think that kind of boundary between challenging you and making you feel like it's, you know, you're just, it's impossible, as noted here, that's not really what we're after. So yeah, I think I can kind of say a few words, but extend the deadline now. Well, yeah, I mean, those people who asked me in advance, they'd get the deadline extended earlier. I didn't give a blanket extension to the deadline because people weren't asking about it. So now, seeing the feedback and people struggling, yes, I think I would extend the deadline now. I'm sorry that you've been stressed or anxious about this exercise, but again, if you ask in advance, I'm generally very willing to extend deadlines. So sorry for making this week stressful for you. However, I'm hoping that at least in some sense, extending the deadline now will still be beneficial to you, as I think the exercise for this week, for week 7, is a little bit less challenging. And I think that will hopefully mean you still have time, if you want to finish up or to spend a bit more time with exercise number 6, that you can do that. So yeah, I mean, I don't know. There's not really specific questions here that I think I can answer directly in this sense. These are questions that are maybe better to be addressed one-on-one, either in Slack or in one of the exercise sessions. But I can just take a quick look here at exercise number 6. Oops, again, I don't need to have the solution version, but here. So problem 1, I had the impression that beyond reading in the data file, which is definitely sort of a tricky one because there are some things in there that make the format of the data file sort of nasty, most of this, I think, was introduced in the lesson, and I felt like you guys would be in good position to address most of these questions about how many no data values there are and things like that. The number of days that we have and things that, like this type of question, is generally, I think, accessible to you. The finding the average temperature, we've seen how to do taking the mean value of different columns. The one that's a little bit tricky here is finding the average temperature for the summer of 1969, because you have to take a range of dates. And so for that, you have to use the loc function to be able to select a sort of range of dates that starts at some date, and then have a second condition to have your range of dates that ends at some other date. So I think we have also seen this earlier in the course, but I do know that that could be one of the more challenging pieces. So I think, this is one place where I had a few people that were asking questions in Slack, and essentially, once you got the idea for how to use the loc indexing to give you the slice of dates that starts on May 1st, 1969, and ends on the 30th of August in that same year, you then have a selection of ages, and you can then calculate the average temperature for that selection of ages. That exact same idea is used in several different ways in this exercise and in some of the others, like in later parts of this exercise, and also the final project. So that's the basic idea with part 1. So I don't know if there's still questions about that. I would say, again, please ask those in Slack or come to one of the exercise sessions if you can. We are generally trying to be fairly accessible. We're not available 24/7 on Slack, of course, but we try to be available there. When I have questions that are sent to me as direct messages, I try to answer them as soon as I can. But of course, I'm, this, just like you having, more than one course going on, I have a lot of things myself. So it's sometimes I'm just not able to respond very quickly, and apologize for that. Where are we here? Exercise 6. So yeah, problem number 2 essentially gets into this idea of aggregating the data. So in the data file that we have, the observations that we have here, I believe, are given as daily values. So it's going to be a single, if we click on the data file here and just have a look, it's kind of big, so it takes a little while. But what you can see, if you look at the data file, is that there's one temperature observation for each day. So this is 1952, January 2nd, 1952, January 3rd, and so on. So we have one daily temperature value in the data file. As long as we're not missing data, we should have a temperature for each day as an average. Part 2 is basically to take temperatures from daily values and convert them to monthly averages. And in order to do that, we have to do some of the string splitting stuff that we did in the lesson, where we have this date represented as this 8-character thing. So there would be 4 characters for the year, 2 characters for the month, 2 characters for the day. And we need to sort of grab just the pieces of that that we need in order to calculate a monthly average. If we want the average of every single month, we would only need to grab the month characters. But if we want the average for the month of a given year, we need basically the first 6 characters. So just to show you here quickly, if we had some date in this format, we could say 1952, and let's make it the 3rd month and the 9th day. Something like that. And that's the date that we have for one row in our data frame. And if we wanted to take, well, let me make another date here. Let's make a date 2, and we'll do it 1952, and we'll do the same month, but a different day. Let's say the 12th of March. The thing that these 2 dates will have in common is the same year and the same month. But of course, the last 2 characters are different. If we wanted to average all of the temperature values for the month of March in the year 1952, essentially what we can do is we can take a slice of our string here. Now, we showed a little bit different way to do it in pandas, because there's a sort of specific methods you can use for working in pandas. But if we were to take, for instance, our date here and just take the first 6 digits or the first 6 characters of our date, this is a sort of selection where we start at position 0 and go up to, but don't include, the index number 6. So each one of these characters would be 0, 1, 2, 3, 4, 5, 6. We get from that the selection. Oops, I don't know why that's doing that. We get the selection here of 1952-03. So if we had a data frame, for example, containing these values, and we filled in a column that contained these 6 characters for every one of the dates we have, what you could see is if we took our date and our date 2 and did the same operation there, take 0 to 6, we have basically the same string that gets returned here. And that's what allows us to do the grouping. So when these 2 things both have the same year and the same month, we can group them together so that if we had a data frame, for example, and we had added this column in for the year and the month, we would be able to group everything together by the year and month. And then once we can group it, we can do things like calculate an average temperature. So that was something that we showed during the lesson. I think doing somewhat similar operation, maybe. I don't remember whether we were doing temperature values for the day or for the, I think it was also done for the monthly average. But essentially that's the idea for what you need to do in the second part of the exercise, is to basically group together these temperatures, including both the year and the month, to get a monthly average temperature for that month of that year. So again, if we wanted to group only by the month, which is something you do in part 3, it's a little bit different. But because we want to make sure that we're getting the average for that month of that year, we need to have all 6 of these characters here. I hope that's somewhat clear. I want to maybe just go here one more time now. So that's basically what you're doing, is you're kind of grouping things to get a monthly average. And then you are, I think, in this problem also doing your conversion from Fahrenheit to Celsius. So that's the other part. Problem 3, I think, is, I guess, yeah, this problem 3 is maybe where most people got to having trouble. So I guess I went through problems 1 and 2 thinking there were parts 1 and 2. Sorry about that. But yeah, problem 3 is where I think people were having most of the trouble. And the thing is, I think this comes partially from the kind of concept of the problem, that it's a little bit difficult maybe to understand what you're supposed to do. And we've tried to kind of explain this a few different ways. It's a little bit tricky to come up with a good explanation, but in essence, you're doing a couple different calculations. And yes, this is definitely the more challenging part of the exercise. I will say that this is something that you will come back to looking at in the final exercise. So it's worthwhile to spend the time here to try to make sure that you feel like you understand what to do in this part. And individually, I would suggest that you do that, either through talking with us in Slack or coming to the exercise sessions. But I'll just give you a quick overview of like what the basic idea here is for part 1 and part 2. And then we should probably continue on to today's lesson a little bit, because we do have some material, of course, that we should cover. So the idea in part 1 is that what we want to do in the problem is to calculate a temperature anomaly. What that means for us is we want to say, okay, how much different is the temperature in some month of a given year? So let's say March of 1952 compared to a typical March. And the typical March part is what you're doing, or your typical month part is what you're doing in part 1. So we're taking a selection of our temperature data from 1952 and up to and through 1980. For this period of time, we have selected all of the temperature data, and we're going to say, let's take the month of March from all of these years and figure out what is the average temperature for the month of March. And you would come up with something here like minus 3.87 degrees for this location for the month of March. The whole point here is to basically put together our kind of 12 different values that tell us what the typical temperature would be for January, February, March, April, May, etc. In order to do that, you have to do 2 things. One is you have to select from your data frame the monthly temperatures that you would have calculated in the previous problem for the years 1952 and through 1980. So you take that selection of data, and then what you need to do is you need to take from the date just the month. So what we saw previously in wherever I put it, I guess here, is we had these date examples, and this is date format that what we're working with, where we had taken a selection that gave us the year and the month. The difference here maybe becomes more clear if we add in a third date. So let's add in date 3. Sorry for not doing this in a data frame. I probably could, but I just didn't want to load a data file and start messing with that. So let's take the year 1953, but still March, and let's take the 15th now for our date 3. So if we want to average all of the months, what we need to do from each one of our dates is take the selection of the part of the date that only is going to give us the month. So that we say, like, look, we want March, even 1953, 1954, all of these years, we want to take every single temperature we have for March and average them all together. So for our date, for example, we know that we don't want the year. So we can ignore the first 4 characters. And the slice that we want to take in this case is just 4 to 6. So that's going to give us, we're skipping 0, 1, 2, 3, 4, 5, and then we skip 6 because the last number is not included in our selection. So we can see, for instance, here that we get 0, 3 coming back. And if I was to print all of these, which I'll just do quickly like this, do a little copy paste. And then fix this up. So we do it for date 2 and for date 3. If I print those out, then I can see that I'm getting the month, the month, the month only from these dates. And here, even though the year's different, I still get the same thing. If I was to make a column in my data frame containing just these values now, so I've taken my selection of dates for the years 1952 through 1980, I make a new column containing only this piece. So only the month. I can then group things together by the month. And once I can group everything by the month, it's easy to calculate the mean temperature at that point. I think the challenge here is to figure out, how do I want to group things? What do I need to do differently from, for instance, the previous problem where you were taking daily measurements and grouping them by the month and year? Here we want to group only by the month, but for a selection of dates from 1952 through 1980. I think that's the challenge that exists in part one. And I hope maybe that helps you in a sense, because basically that's, once you've done this part of selecting only the month, then you can group by the month and do your mean temperatures for each of the months. And I think you should find that should be fairly clear at that point in terms of how to proceed with part one. And that will give you then these reference temperatures. So these are the temperatures that we're going to compare against when we want to look at the temperature anomalies. The whole point is that if we think, for instance, the month of January has been getting warmer over the past 100 years or something like that, in order to see whether it's been getting warmer, it's easier to look at the temperature compared to a typical January to see if it's higher or lower than normal, rather than the actual temperature values themselves, where it could be a bit harder to see. So that's part one, just as a kind of quick overview. And then for part two, we have to do one additional challenging thing here, and that is to join together these two data frames that we have. So we do a table join. There's a hint for this in the exercise hints for the week. But basically, we have two data frames at this point. We have monthly data, which is going to give us our temperature values for each month of each year. And we have ref temps, which is basically just 12 different temperature values. But in both cases, we would have a column called month that would have, for instance, here just 03, 02, 01, or whatever. What that means is that we can say, tell pandas that wherever you find the month is the same between the two tables, you can join their data together, such that if in our monthly data we had this column containing month that said 01, we could then also add in a ref temp column where every place it finds month of 01, it would put in this reference temperature. The benefit for that is that we can then easily subtract a temperature that's in our monthly data table, or subtract the reference temperature, for instance, from the temperature in the data table. And then that way, that difference that we calculate will tell us whether the temperature is hotter or colder than normal. I had made this little diagram. I'm not really sure whether this actually helps. So I apologize if that didn't make things more clear. But the basic idea hinges here on getting these reference temperatures for each month to be in our data table, so that we can take the average temperature for January of 1952, subtract this reference temperature for our typical January, and then in that way calculate a temperature difference. So yeah, I mean, this is maybe not exactly a complete beginner topic, but I thought at least the thinking has been in the course in the past few years as we've developed things, that this is actually kind of a really nice example of what you can do. Even though it's a little bit more challenging, it kind of gives you a sense of doing a little bit more sophisticated data analysis to produce something meaningful, because now we can look at climate trends over the past 100 years and see where temperatures are warming. And once we've built this sort of data processing workflow, we have one data file that we're working with, but we could very easily have hundreds and do the same set of operations to produce this for many different stations across the country. So yeah, I think I won't say a great deal more about that at this point, unless there are any urgent questions. And yeah, I would once again maybe encourage you to talk with the course assistants, talk with myself if you have questions. And again, I do realize that extending the deadline at this point might feel like a bit of an empty gesture. I don't want it to be that. I basically just was only aware of some cases of people having difficulty with this exercise. It comes up much more here at this point, but for those who had contacted me earlier, I was willing to extend deadlines, and I basically just didn't do that to everyone because I was not aware that there were this many people having difficulty with this exercise. So apologies for that. Yes, so there's one question here under the general questions. I think I've kind of covered the comments above. Supposed to be a project to do. Will that be introduced this week? Yes, it will, and we'll get to that a bit later in the lesson for today. So yeah, I think we should probably move on. And if you have anything urgent that comes up in the meantime, just say something in the chat, please, and we can continue from here. So I'm just going to refresh the course page. I think you should all now see that lesson 7 is available, as well as the final exercise. We'll get there, so please maybe just hold off on jumping ahead to looking at the final exercise for the moment. And our goal for this week is essentially to look at data visualization. And so we'll do a little bit of plotting using pandas and also the Matplotlib library that is used kind of under the hood in pandas, but in some cases we actually need to use explicitly in order to be able to do certain kinds of plot formatting operations, basically. So we'll learn how to make some XY plots, how to do some bar plots and things like that, how to play with the formatting of our plots, and how to both insert the plots in Jupyter notebooks and also save them separately as image files. So that's the kind of overall goal for this week's lesson. What we're going to introduce to you is plotting through pandas, because we've been learning pandas, and this is the easiest way to make a step toward generating plots from the data that we're working with. We can very easily take things from our data frame and just directly plot them. In fact, I think we've already seen some very simple examples of doing that. But this is the landscape in terms of what plotting looks like in Python. There's a lot of different options, which can be good and bad, but sort of maybe the thing that comes through here is that it can be a little bit overwhelming if you're completely new to plotting. So here we are with pandas. As you can see, it's connected to Matplotlib. So this kind of like network diagram, or whatever you want to call it, is showing the relationships between these different plotting tools. So pandas is like directly connected to Matplotlib, which basically means that under the plot commands that are using in pandas are calling things from Matplotlib. But you can see there are other types of plotting libraries that also use Matplotlib, including Seaborn. Some of you may have heard of Seaborn previously. Holoviews is one that we're testing out at the moment as a possible thing to introduce in future parts of the course. But we'll also see a little bit of a library called Bokeh today. And Bokeh we can use through pandas with a sort of intuitively named package called pandas Bokeh. Bokeh allows us to make interactive plots, so it's kind of cool in that sense, because you can click and turn things on and off, zoom in and whatever, interact with your plots once they've been created. And so that's kind of a nice thing with Bokeh. And but otherwise, there are many different options that exist out there in the Python plotting landscape. And this is just the point of this part of the lesson is to kind of introduce that they exist and to provide you some links to some commonly used plotting libraries. So Matplotlib is probably the most common. And if you go Googling around for different options for plotting in Python, you're going to find a lot of examples using Matplotlib. And so it's designed to give you kind of MATLAB-like plotting. So it operates very much in the same way as plotting with MATLAB. For those who know MATLAB, you might see some similarity there. But if you wanted to have an example of what kind of things you can do with Matplotlib, there is the gallery here. So just open this up and you can look through here, for example, to see the different styles of plots that you can make. You can see there are lots of different possibilities for plotting with Matplotlib. You can plot images, you can plot all kinds of different vector diagrams, pie charts, and there's lots of examples of using colors and labels and things like this. What's nice in the Matplotlib gallery is if you find a plot that looks something like what you would want to create. So let's say that you had wanted to create some kind of, I don't know, plot like this with some curves with a fill between the curve and the axis line. You can click to see the plot, but it actually also provides you with an example code to be able to reproduce that plot. So I guess I'm looking at an old version of this document. It looks like it has been updated, but I'm just going to go back here for right now. But the point is that, yeah, this is really handy with this gallery because you can get a quick look at a style of plot, and then you can get an example from the code that's here, and then you can start modifying things to suit your purposes, which is quite handy. And obviously, there are lots of different styles of plots, and even some examples with widgets. I don't see this one loading, but usually widgets would allow you to sort of interact with the plot in some way. But I've used, for example, things like this scatter histogram as an example of a plot style that I wanted to make on my own with figuring out how to do these axes on the sides, and it's quite handy. I've already mentioned a little bit about bokeh for doing interactive plots. We'll see that later in the course, but similar to Matplotlib, sorry, there is also a bokeh gallery. So you can, for instance, go there and see some of the examples of the bokeh plotting. And again, if you click on one of them, it will load like this, and you can see what things look like in bokeh and how you can, for instance, interact with different plot elements. I guess this was originally showing miles per gallon versus horsepower or something like that. But then you could color things by acceleration or whatever, make the size be related to some other factor. So this is kind of nice because you can tinker with the plot, and for users, it's nice to be able to interact with the data. You can also do things like click and zoom into a certain area on the plot. And if you mouse over any of the points there, it tells you the information that is plotted, which is also a nice way to be able to understand more about the data that you're looking at. So we'll play a little bit with pandas bokeh very briefly, but you'll see at least that it's not hard to make these kind of interactive plots. There are a few other options that are mentioned here. I'm not going to say much about these. You can have a look at the course page if you're curious, but whole of views is one that, as I mentioned, we're considering introducing in the future because it allows us to do things like make interactive plots from pandas even more easily than pandas bokeh. And it's very flexible so that you could even use other plotting backends to generate interactive plots. So we basically would encourage you, if you're curious, once you've learned a little bit about plotting in this first lesson, to take a look at the different options and explore the galleries and see if you can reproduce some of the plots. Now, before we proceed into making our own plots, I'm just going to get rid of these extra tabs. We kind of need to talk a little bit about terminology and some basic elements of a plot. There are lots of different styles of plots or graphs or charts or whatever. They even go by different names in some cases that we could create, some of which are probably very familiar. So like if we click here on the bar chart link, it takes you to Wikipedia where you can see examples of bar charts, and certainly you will have seen this kind of chart before. These are quite common. Line charts are similar kind of thing. Of course, we have seen line charts, all of us, previously, but there may also be some that are less familiar to you: violin plots, chord diagrams, dendrograms, network charts. We were sort of looking at a network type chart just a moment ago. And these links will take you, if you're curious to see, what is the dendrogram, these links will take you to Wikipedia where you can see exactly what those different styles of charts are. Now, not everything that's on these different styles of charts is the same, but there are a lot of elements that are very similar. And so we have created a little picture here to illustrate some of the names of the different features of the chart. You've made charts, I would imagine, before in Excel or something like that. And you would then know, of course, that there are titles and there are axes. There are labels for the axes. So for instance, the Y label or the X label, and these would be then the X and Y axes. Typically, we use Cartesian axes. In our plotting, we'll also encounter things. Probably we won't mess with the padding, but if you want to change how far a label is from an axis line, for example, there's padding, there's default values, and you can increase or decrease that. There's fills that you can add. So between two lines, you could fill in the region between them in color. The lines themselves, of course, are just called lines in this case. But then we can also add annotations, so we can put text on the plot. So for instance, here where it says highest peak, we can have text there. There's grid lines and ticks and tick labels and all of these different pieces of the chart that you can see here. And basically, these are the names that are used in Matplotlib. So you're aware of them and know then what to look for if you want to, for instance, make changes to the legend for one of your plots. You can also find down below a list of these different terms and a description for what they mean. It's the same information, more or less, that's shown here with a little bit of extra text describing those parts of the chart. So this is mostly for reference to allow you to be able to look things up and figure out what to call something when you're trying to modify your plots. Okay, so let's get to the lesson itself now. And for this, I'm going to go over here to the CSC notebooks, go into my notebooks folder and lesson 7. As it was noted on the screen before, we'd encourage you to use the Geo-Python Lite or Geo-Python 2021 Lite instance for this week's lesson, just because we're downloading data again. And if you're using the other regular Geo-Python, you may run out of disk space in your cloud instance if you don't. But our first lesson here is just called Matplotlib. So I'm going to double click on that to open it up. And we can get started by downloading the data. This is more or less the same process we went through last week. So this will look familiar. The difference is that we don't have two different data files for this week. There was some for, if you were using the regular Geo-Python or using the Geo-Python Lite. But it's all the same single data file this time. And we basically just need to download it. I'm going to do that by going here to the terminal. So I'm going to go to File, New, and then Terminal. Just here. Open up a terminal, and then I'm going to grab the tab and drag it down here to the lower half of the screen so I can see the notebook and see the terminal at the same time. Now, in the terminal, I can type ls to see what directory I'm in. I can see, for instance, that it looks like I'm in the home or kind of base directory where I can see notebooks. And so what I want to do is type cd notebooks /L7. And then I can hit enter. That'll change the directory I'm in to be this lesson 7 directory where we want to be working today. And if I type ls, I can see now the Matplotlib notebook and the advanced plotting notebook. Those should both hopefully be visible to you as well. And then just like last week, what we're going to do is use this wget command. So I'm just going to copy this one, or you can type it in if you are looking for something fun to do. I'll type wget or paste it in here to download the data file. It's much smaller than last week, so it should download very quickly. And then to extract it, I just need to copy and paste this command here. And when I paste that in, I'll see a few error messages, or actually warning messages that we can just ignore. And if I type ls now, I can see the data directory that was not there previously. So I would suggest that you do these steps, and once you've done it, could you put a green check mark in Zoom so that we know everybody is ready to continue? It's good to download the data so that you're able to do the lesson. Otherwise, you can follow along, of course, but it's nicer to be able to do things interactively as we work. So put a green check mark when you're ready, and we'll continue in just a moment. So I'll continue. If you're having problems, please say something in the chat. But otherwise, we can continue at this point. So I'm going to just drag my terminal back up to the top here and switch over so I can see my screen a bit more clearly. And in fact, I will also zoom in just a little bit here to make this a bit bigger for the lesson, because why not? Okay. So you should have the data at this point. It's actually the same or part of the same data set we used last week. So it's just one of the stations we were working with from last week's exercise. So I suppose there's not a need to explain the data format in a great deal of, a great deal of detail. But yeah, we have basically the same thing. We're working with these kind of multiple observations per day, temperature data. I don't recall offhand which station we're working with, but it doesn't really make a great deal of difference for our plotting exercise as is. The data format looks more or less like this. We've dealt with it before, and we can get started right away just with dealing with this because we know already some things about how to handle this data file format. So of course we can start by importing pandas, as we always would do in order to work with pandas. We're going to be using a date time index with our data today that we're loading in. So we talked a little bit about date times last week, went through it fairly quickly in the lesson. It's mostly just going to allow us to use a way of selecting our data on the basis of the date as the index rather than like a numerical index like 0, 1, 2, and so on. So we have to, in order to deal with this date time, we have to make a couple changes to how we've loaded the data file in from previous examples. A big part of doing it this way is because the plotting will look a lot nicer if we use the date time indexing than if we use the numerical values that are used for the date. So not to distract us too much, but just to jump here, for instance, if we were to interpret this value as a number for a plot, 1953-0315, okay, that looks like our date format, but it's the same thing as 19,530,315. If that's our number for our date, that can be that our observations will be sort of spaced out weirdly, because you could imagine that when you go from 1952, let's say, December 31st of 1952, last day of 1952, to the first day of 1953, that would be 1 day difference in terms of the calendar. But if you were to interpret these numbers as actual numerical values on an axis, like the x-axis of our plot, we would go from 1952, 12/31 to 1953, 01/01. And there would be a big gap every time we change years. So that's part of the reason why we want to use date times here, is because it will interpret these values for our plotting a little bit more nicely. You don't need to make any changes to what's already in the cell here. I'll just point out a couple things. One is that we're going to use this parse dates parameter. So this will allow us to list a single or multiple columns that have date values in them. And then pandas will try to convert those dates to date time values. And then the second thing we add here is this index call. So this says to use the index column from these dates that are going to come in. So this essentially will allow us to use our date time index. So I'm just going to shift enter to run that. And it will take a moment because there are a fair number of observations in the data file. It takes a second for it to load everything in. So while we're waiting, just a reminder here that we're using two new parameters, parse dates, in order to convert the text, like 1952-0101, to being January 1st, 1952, as a date time. And then we also have this index column that's going to be used to tell us which of our columns should be used in place of the normal indexing, which would just start at 0 and continue on from there. Okay, hopefully your data will have loaded relatively soon so that you can run now data.head, and you can see what we're dealing with. You'll note that with the use calls was used here to take only a selection of columns out of our data. So we have the date, temperature, max, and min. And so here we have data.head now showing us that over here, where our index would previously be 0, 1, 2, and so on, we have here our date times. So 1952, 1st of January at sort of the start of the day, and then at 6 a.m., and then at 12 noon, 6 p.m., and so on. Every 6 hours, it looks like we have a temperature observation in this data file. And you can see then the temperatures and the max and min, if they did make sense to be listed there, then those are there as well. So those are our temperature data. And you can see the main thing here is that we now have this indexing that's a date time object. To make our first plot, we can do a relatively simple thing. We'll say AX equals data.plot. So I think we had seen an example of doing data.plot earlier in one of the other lessons when we first introduced pandas to just show how easy it is to do a plot. Here we're going to do also this data.plot, but we're going to assign it to a variable called AX for the axis. This is a very typical way to do things because sometimes you create the plot with one command and then later modify something on the plot. And in order to do that, you need to have a variable you can refer to. But if you just run this cell, what you'll see after a moment is you should see some wiggles. Let's give it a minute here and see what we get. Okay, so it's a little bit messy, but what you can see are some temperature values. It looks like we have observations here from maybe beginning sometime 1950s, 1952 perhaps, through I think 2019. And there's a small gap in the data in the sort of mid 60s to early 70s, but otherwise we've got a bunch of things here that looks sort of messy when we're zoomed out this far in terms of the range of dates. But we use .plot or data.plot to create this plot, and then all of the column values that are here, temp, max, and min, are then plotted, and we can see a bit of the temperatures there. We also assigned this to this variable called AX. So if we check the type of AX, which we can just do here, you'll see it is a Matplotlib axes subplots type of object. This is a little bit longer object type, but the key thing here to note is that this is something that we did dataframe.plot, so data.plot to create the plot, but you can see it's a Matplotlib object that gets created. So our plotting is indeed being done by Matplotlib. Okay, so we've created this very simple plot, and now let's have a look in a little bit more detail by zooming in the temperature range so that we can see things a little more clearly. Right now we have so many wiggles, it's just almost impossible to see what we're plotting. So let's take a look at temperatures from only a single day. In fact, let's just take the afternoon of the 1st of October of 2019. That's the latest day in the data set that we're working with here. So we can make something here. Let's call it Oct1 temps. We'll take a selection of our data. So we'll take only the temp column in this case. And we'll use the .loc indexing to give us temp or dates where our index, so data.index, is greater than or equal to, and then here I'm going to give 2019 October, so that's 10, the first 0, 1, and then we're saying the afternoon, so it has to be greater than or equal to 12 o'clock, 12 noon on the 1st of October. Because our data set goes up through and basically the only, ends on the end of the day on October 1st, we can include only this one condition here for the dates that we're selecting, and that is that the index, because the index here is a date, has to be greater than, or not approximately equal to, but greater than or equal to 2019 October 1st at 12 o'clock in the afternoon. So that'll give us a selection. That'll also be a data frame, but it'll just be a selected range of dates so that we could then go AX equals now oct1 temps dot plot. So more or less the same thing we did before, but now we've just changed it so that we're not using the whole data frame, just one piece of it. And if I run that, now what I can see is a little bit more zoomed in picture of the temperature observations that we have. So you can see here, October 1st, 12 o'clock, October 1st at 2 in the afternoon, 4, 6, 8, 10 o'clock at night, and then midnight of the 2nd of October. And we don't actually have any data for that last point after that. So we've done a couple small differences here. Obviously, we selected a range of dates, and we've only used a single column out of our data frame. So we've only used the temp column here just to plot the one line there. The loc in this case, we were able to actually do the comparison using this character string in the format of year, 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 month, month, day, day, hour, hour, minute, minute, which is what has been done here. And pandas, fortunately for us, will recognize this character string and convert that to a date so that when it compares against the index, it's able to select only those values for the afternoon of October 1st, 2019. So that's something we can continue to work with a little bit. We'll just use this subset of the data going forward just because it'll make things a bit easier. Let's now play around a little bit with our format of our plots to make things look a little bit nicer. So we can do that. Again, here, we'll start by changing our line and symbol format, and then we could add some axis labels and a title. So actually, let's do it like this. Let's copy what we had before, just so you can see what's different. Paste that in here. We haven't given any parameters when we called the plot function before. We've just used the default things. First thing we can give here is a style parameter. And we'll say style equals, I think in the example we used R, O, let's use, how about G-O dash dash. I'll explain what that means in just a minute. So we can set a style, we can add a title using the title parameter. That one's a nice intuitive one. And let's say this is Helsinki Vanta temperatures. And we'll add a comma here, go on to the next line. We can add an X label. So that'll be the label for the X-axis. Again, put that in quotes. So our X-axis in this plot is going to be the date. That's an easy one to add. We can add a Y label. And that one is going to be, in this case, the temperature. And I guess we can put this in Fahrenheit. If you want, you can do the degree symbol, but I never remember which one it is. On a Mac keyboard, at least for me, it's Option Shift Q. I think that's on the Finnish keyboard. I think on an American English or International English, it would be Option Shift 8. But whatever, you can put the degree sign if you know how to do that. yeah, so we've changed our line style, we've added a title, we've added some axis labels. Let's see what this does for us when we run it. Okay, so now we have some things added here. Our title, axis labels are there. That looks good. Plot tells us more information now because previously we didn't know what these were. These numbers on this axis. I guess we could probably guess this was a date on the horizontal axis. But the style, if we break that down for just a second, the G here is the shorthand for telling the style to use green for the color. If you change it to R, it would use red. If you change it to B, it would use blue. If you want black, it's actually the letter K because there's B for blue and K is the last letter in black. And there are some other color options as well, but that just allows us to change that. The O here tells us which symbol to use to plot the points. So previously we didn't see any symbol that was used in our earlier plot. We just saw a blue line. Now we have this sort of circles that are used. I think if we did D to do diamonds, yeah, so you can change it if you want to use diamonds, or you can use S for squares. You can kind of play. There's a link that is here in the lesson that will show you how to get these different options for the symbols. And then the double dashed line here tells us to use a dashed line for the line connecting the points. I suppose the title and axis label part is somewhat intuitive. But yeah, if you go to the documentation on the Pandas website, just click the link here. It will take you to the way in which you can specify things for the plotting. So if, for instance, we don't want to use style, you can also separately use color. And color, for instance, allows you to be a little bit more specific. Like here, right now, there's only maybe 8 different color options you can use with a single letter. So if we take away that G for the style here, it will default back to blue. But we could add then in here if we wanted color equals, and then you can give, there's some labeled colors or named colors for Matplotlib that can be used. So we could, for instance, say light gray as the color, and we run that and we get light gray here. There's also, I don't know, purple or many other color options that could be used there. Even things, I think there's something like tab, blue, green, I don't know. Yeah, there's these all kinds of different named colors. I think there's a link in this week's exercise about how to specify the colors. So, or maybe it's later in the lesson, I don't remember. But you can specify that separately if you want to. It just has to be a name that's recognized. So you can't put, like Dave, I don't know, blue or something. It won't recognize that that's a valid color because that named color doesn't exist to Matplotlib. But if I said dark blue, that would be perfectly fine because there is a named color called dark blue that's available in Matplotlib. Okay, so if you want to know more about the plotting, you can go to the Pandas website or you can type help and then get ready for this one, oct1 temps.plot. When you run this, it's going to produce a lot of output, but it tells you how the plotting works in Pandas for the plotting and how you can specify things for all of the different values that are available for controlling the formatting of your plot. So that's a nice thing to know about. But of course, be aware it does produce a fairly large amount of screen output here because it describes all of the different plot styles and things that are available in Pandas. And as I continue scrolling, you can see there's quite a lot of information that comes out here. All right. Now, the unfortunate thing is I want to go back up to grab our example from way back up here. I'm going to copy what we have done so far. Just copy our plot command because we can use that down here. You might want to do the same thing. Just copy what we just plotted down to this next box about embiggening the plot. So this is a silly Simpsons reference to the word embiggen, but essentially means changing the plot size, making it bigger in this instance. If I paste this in here, what we had just plotted before, I'm going to take exactly what we had just done, but I'm going to add in one extra parameter. So if I add another comma here, I can now add in a fig size parameter, and then I have to list something in parentheses. This is called a tuple in Python. It's kind of like a collection, like a list, except for the values would not be something you could modify once they're defined. But if I said 12, comma 6, that will make the figure size so that if it were printed, it would be 12 inches wide and 6 inches tall. Because it's Matplotlib and developed in the US, inches is the default value that's used for scaling of figure sizes in Matplotlib, so be aware of that. If I run this though, now what you can see is the plot has gotten bigger and now perhaps is a bit easier to see. In our example, it was probably perfectly fine the size it was, but it's not a bad thing to have a little bit larger plot size to make it easier to read. And so that's all we've done here by adding the fig size parameter. It's also possible, if you're curious, to change the default plot size. You can do that by importing the Matplotlib pyplot library at the beginning, and then running this command to set the default figure size to be something different, like here, 12, 6. This is given as a list in this when doing it this way instead of a tuple, but essentially this idea is the same. After you've run this command somewhere in the notebook, then all of the figures that you create by default will be this size, 12 inches by 6 inches, rather than the default, which I think is maybe 8 by 5 or something like that. Okay. We can also add text to our plot using ax.text. The way it works basically is that you would say here ax would refer to some plot object that exists, and then the text command expects to have a position x and a position y where the text is going to be displayed on the plot. So this should be like coordinates on the plot. So in our case, it'd be like some date and some temperature. And then the text you want to display itself is given in quotation marks. You could also put an F string here if you want. That's a perfectly fine thing to do. In addition, it's possible to change the axis ranges, as you might imagine. So you can do that by setting X lim and Y lim. So this will define the values from the minimum and maximum value on the x-axis, minimum and maximum value on the y-axis. And so we can add that in. And when we're dealing with our date time axes, the one thing we have to sometimes handle here is converting things like a bit of text we want to display on the plot to a date time object in order to be able to position it on the plot properly. So while pandas is able to interpret some things for us very easily about date times, like when we said, let's take our slice using the .loc example of, dates that are after the noon on the 1st of October, 2019, that was no problem. Here, we do have to do a conversion of this same string, for example, or a string of values that would represent a date to a date time object in order to be able to position the text on a plot. So if we have, for instance, this string here, if I just copy this and paste it in here, so that's 2019, 10th month, so the October, first day at 1 o'clock in the afternoon. We can convert that to a date time using pd.to_date time, and then putting that string in parentheses there. And if you run that, what you'll see is it gets converted to something now. It says timestamp 2019, October 1st at 1 o'clock in the afternoon. So in order to position our text, we basically need to to do that. And the same thing actually can be useful for defining the X and Y axis limits in modifying our plot. So if we take the same plot, this is kind of the expected plot that we would have at this point from what we've done above. We can add in a couple things like, let's change our plot so that now it starts at noon and ends at 3 p.m. on the 1st of October. And we only look at temperatures between 40 and 46 degrees Fahrenheit. And then we can add some text that will note the coldest part of the day, which occurs in the early afternoon. So let's define a couple things here. Start time. So this is when we want to start our range of values on our plot. And we'll do pd.date or to_date time. And now this is supposed to be noon on the 1st of October of 2019. So 2019, 10:01, 12:00. Okay, I'm going to copy this because it'll be easier if I just copy and paste it to do the next one, which is the end time. So that should be 3 p.m. So we'll just call that end_time. PD to date time, 2019, same day. So same day of the same month, but instead of 12, we're going to say 15:00 for 3 p.m. on the 1st of October. And then lastly, we can add cold_time. And again, I'm just going to copy what I have above to say PD2 date time. Our cold time is going to be at 12:05 in this case. So 12:05 p.m. And that gives us our cold time. So again, we're doing this to date time conversion to give us things that we can put on the plot, or we can change the axis range more easily. These are things that are not happening directly within pandas, which is why we have to convert them to date times first. Then we have our plot statement, which is basically what we were showing before, that exists as we've seen it previously. But now we need to add our text to our plot using ax.text, as we have just seen. Our x coordinate is going to be cold time, because that's the time along, if we scroll back up to our plot that we last saw here, our x values are the date. And so we want the cold time here to be at the cold time for this part of the afternoon we're looking at. The y coordinate in this case is going to be the temperature at that cold time, which is, I just happen to know, 42 degrees. And then there's the text we want to display here. And what we could do is we can make a little text arrow and say coldest temperature in early afternoon. Whatever, you can put whatever text you want there. If I run this now, I've defined these dates and I've now done this modification. There's one thing we're missing, and that is to actually add the change to the axis limits. And again, we can do that by defining xlim equals, and then this should be a Python list with the starting date and the ending date. So start time, end time, and then ylim equals, again, Python list, 40.0 and 46.0. So this was what was told for us for the temperature range that we should have here. So we've added our dates, we've added our change to our axis limits, and now we've added this text to display. And if I run this, you should hopefully see a plot that looks like this. So what's changed from before is now we go from noon until 3 p.m. Our range of temperature goes from 40 to 46 degrees, which works nicely for the temperatures we have for this part of the day. And then we've added, of course, some text here pointing over to this point to indicate it's the coldest temperature in the early afternoon. Okay, we have a few little things left to do in this lesson, but it's 10:30 now. So I think what we can do is maybe we can do this check your understanding option. So you can take what's in the cell above and maybe copy and modify it to show the following. So temperature data from 6 p.m. till midnight on the 1st of October. Use a dotted black line connecting the observations with no symbol used to show the data points. Add a title that reads the text that is here, and then maybe you can add a text label that shows the warmest temperature in the evening, and you can do that in the box that's here. Why don't we go ahead and take, let's say 15 minutes. So you have some time to do this check your understanding thing, and then we'll continue at, let's say 10:45. So it was 15 minutes a minute ago. So we'll continue at 10:45, but please, in the meantime, while doing the break, do this check your understanding, and then we'll come back, review that, and continue with the bar plots in pandas after that.